Welcome to Peninsula Seniors Out and About. We're at the Western Museum of Flight in Torrance. Let's go see what Cindy has for us today.
Welcome everyone to the Western Museum of Flight. I'm Cindy Maka, the director. For those of you who have not seen the movie Martian, the story involves a near disaster for one intrepid individual who was left behind on the Martian surface and had to use exceptional intellect, skill, and determination to survive long enough for a rescue party to return to the Red Planet and retrieve him. This is, of course, purely fictional, and any real story would probably not unfold that way. Even so, the real stories of human space exploration involved plenty of hazards, triumphs, and unfortunately, tragedies. Fortunately, the tragedies have been few, and some near tragedies were averted, often by the application of exceptional human ingenuity. And all of the triumphs required a full measure of intellect, skill, and determination. Today, we are fortunate to have one of those individuals who has both demonstrated and benefited from those exceptional human qualities. So now, I will disconnect my umbilical and drift off while Dr. Drew Feustel shares some definitely non-fictional stories from humankind's amazing saga of space exploration. Drew?
Thanks to everybody for coming out today. I do have my phone up here, but it's not because I'm checking email. I'm actually controlling the slideshow over here, so don't think I'm too distracted by what's in front of me. There's a little bit of my bio here on the screen, sort of things that I've done in my career on my way to becoming an astronaut. I grew up in Michigan and lived there my whole life, went to high school there, attended community college for 3 years before I went off to get a degree at Purdue University, an undergraduate degree in solid earth sciences, so I'm a geologist. Stayed at Purdue for a few more years and received a master's degree in geophysics. And then went off and to Queen's University in Kingston, Ontario, Canada, where I received my PhD in seismology. Really, Queen's? Yeah? All right. So I lived in Canada for 5 years of my life and had 2 boys up there in Canada along with my wife. I had 2 kids in school while I was at school up in Canada, and then went to Houston to work for the ExxonMobil Oil Company for about 3.5 years. So I worked in the mining industry in Canada, and then came down to the States to work for ExxonMobil for 3.5 years as a geophysicist. And then in 1999, I applied to NASA for the position of an astronaut, a mission specialist, and I was selected in the year 2000. So I've been an astronaut for 15 years, and I've been fortunate enough to fly on 2 missions to space, on Space Shuttle Atlantis and Space Shuttle Endeavour. And of course, Space Shuttle Endeavour is in the California Science Center. So has everybody seen Space Shuttle Endeavour at the California Science Center? Okay, so forever who's not raising their hand, you're out of here. I'm just kidding. Stick around and hopefully we can encourage you to go take a look at it. And you might want to see it now while it's still horizontal because you can see a lot of the spacecraft, see the underbelly, see what it really looked like when it was in space, and then when it gets into the upright position, it's going to be even more spectacular to go take a look at. So that's who I am. That's how I got to where I am here now, and I'm going to talk about my 2 space flights, where NASA is going in the future, and then we'll have some opportunity for question and answer at the end. So save your questions. I'll save my answers, and there's no question that's too silly to ask, and if I don't know the answer, I'll make something up, and you probably won't know the difference. So I threw this picture in here because a lot of folks that live and work here locally encouraged me to do so. These are, of course, T-38s. That outside the hangar is a T-38, and that aircraft used to belong to us at NASA at the Johnson Space Center in Houston. And I've actually flown in that aircraft multiple times before we retired it. But we used the T-38 aircraft as training jets to get us not only around the country to support different aspects of the space program, but also as what we call crew resource management. So we work together as a team inside that jet. It's the only environment that we have, the only training environment that we have that has real consequences to our actions and our decisions. Everything else we do at NASA involves a simulator, and there's always a button we can push to reset it. But with the jet that actually goes pretty fast, and requires a lot of decision making and planning together as a crew, that's the place where we get some of our best training as astronauts, where we can work together. So anybody who's a flyer here or an aircraft operator, you know what I mean, you know what it takes, and for those of you who have flown jets, you know when they're going 500 knots, you have to make those decisions a lot quicker. So I just wanted to throw this up here. This picture was actually taken when we were flying formation on down for my first launch in 2009. We fly down together as a crew, so my crewmates are in those other jets, and we like to fly tight formation on down to the Cape before we get ready to launch into space. And that picture was taken a long time ago. First thing I want to talk about is I'll talk about my 2 missions, but I'm going to talk first about my first flight, which was 2009, which was STS-125. It's the patch shown on the left, and this was the visit to the Hubble Space Telescope. It was the last flight of astronauts to repair the Hubble Space Telescope, and I was fortunate to get in on that mission and have that be my first opportunity to go to space. We launched into space in May of 2009, and our mission was pretty short. We had a very specific purpose, and that was to head on up into space and catch the telescope and make the repairs and hopefully make it last certified for another 5 years, but we think it's going to last 15 because that was 2009. So we're already on 6 years as it is after the repair. But this was our launch. This was the first time I had ridden a rocket in space. We don't have any simulators that prepare us for an actual rocket launch. We have simulators for everything else, but if you want to know what it's like to ride on a rocket, you actually have to ride on a rocket. And this is a good time to make a point about astronauts. Not everybody would say this about themselves, but I'll say it that, we have to be smart enough to fly the spacecraft home, but we have to be stupid enough to sit on top of this rocket when it's going off into space. So I would say, we're not always the sharpest tools in the shed, right? I mean, there's something a little unusual to be sitting on top of all that rocket fuel. And I can tell you that for the first time I went to space, when the countdown was, reaching 10, my T-minus 10 seconds, I started second guessing the decisions I had made in life and wondered if it was really a good idea to be sitting on top of the rocket at that time. And then slowly got down to, the countdown was 3, and I realized that, no kidding, someone's going to push a button and send us into space on that day. And then we hit 0. And the first flight to space is the fear of the unknown. You have no idea what's going to happen because we have no way to prepare for it. And when the main engines light, the main engines are the 3 engines hanging off the bottom of the shuttle, and then we have the solid rocket boosters on the side, the two white tanks that we always see on the side of the big fuel tank in the middle. When those solid rocket motors light, that's when we lift off. The main engines are already running, but the solid rocket motors light, and it feels like somebody just ran into the back of your chair with a pickup truck. I mean, that's how violent and immediate it is, and we're laying on our backs. And it was the scariest thing and the most amazing thing at the same time. I mean, as soon as it hit, I was surprised, and then I was smiling from ear to ear. And then immediately after liftoff, we had these alarms going off in the cabin. So, I was thinking, this is the best moment of my life. And I was like, this is the worst moment in my life. I'm either going to die in the next 8 minutes or I'm going to be in space. And I didn't know what the outcome was going to be because we trained for years for these flights. And as a mission specialist who rides on what we call the mid-deck, so I'm the guy that goes out and does the work in the spacesuit. I'm not the guy that flies a space shuttle to space. So when you're sitting down there on the bottom deck, you don't spend 2 years of your life training for all the ascent simulations. So I don't sit there and practice flying to space and having the controllers put in all the alarms and have us practice how to respond to those alarms. I'm in the big swimming pool with the space shuttle and the space station underwater with my suit. I'm trying to learn how to do spacewalks. So for me, riding on the middeck, when the alarms started going off, I thought that was it. I thought it was all over. Of course, everybody on the flight deck who's flying it, they've simulated these sorts of things hundreds of times. And this was a real alarm, of course, but fortunately through their training, they knew what to do. And so when I stopped screaming like a baby on the middeck, nobody could hear me because the microphones are shut off downstairs. Then we eventually went on into orbit. And 8 minutes later, we made it to space, about 100 miles up above the planet, and slowly increasing our altitude till we got up to the Hubble Space Telescope. So this was our crew in space. We had 3 veteran flyers and 4 rookies. So the 4 of us on the outside of the image is myself, Megan MacArthur, our robotic arm operator, Greg Johnson in the lower left, and Mike Good were all rookies on this flight, and 3 individuals in the middle. Mike Massimino, who you might know from the Big Bang Theory, Scott Altman, We call him Scooter. Bit of trivia, he was actually in the movie Top Gun. He was the pilot who flew all the operational flights for the Tom Cruise role in the Top Gun movie. So we call him Scooter, good guy. And then John Grunsfeld with the mustache on the right is the guy that we call the Hubble Hugger. This was his third flight to the Hubble Space Telescope, and he is now working at headquarters as the Associate Science Mission Directorate Chief at headquarters. So we were all happy to be there, and this was our destination, the Hubble Space Telescope, approximately 320 miles above the planet. It's about the size of a school bus, so it's not very large, and it orbits on an inclination that's similar to orbiting around the equator of the Earth. So when you go to the Hubble Space Telescope, that's your destination. You're not going anywhere else. You're not going to the telescope and then going to the space station. You can't get to other places from there. So has anybody seen the movie Gravity? So in Gravity, right, they started at the Hubble Space Telescope, and then they went to the International Space Station, then they went to the Chinese Space Station. None of that's real. You can't do any of that stuff for real in space. So if you remember back when we launched in space, this was after Columbia, and we had lost 7 crew members on that fateful morning in January. And what was unique about our flight is at that time they actually demanifested our flight because they felt that unless we could go to a place, a destination in space and have a safe haven, which is the International Space Station, that we needed some safeguards in place. And so what we did for our launch on STS-125 is they had another space shuttle on the pad at the Kennedy Space Center ready to go to space and support us as a rescue mission. So when we launched, there was another shuttle on the pad ready to launch within, I think, about 10 days or 14 days of us flying into space. So we made it to space. Our job was to get out there and do some work and fix a telescope. Megan MacArthur, our robotic arm operator, reached out with the Canadarm on the back of Space Shuttle Atlantis and grabbed a hold of the telescope and slowly lowered it into the back of the payload bay of the Space Shuttle. And if you think of the Space Shuttle, it's kind of like a pickup truck, where the back end, we open up the payload bay doors, which are our radiators, to allow some cooling of the avionics on the shuttle, and we place, in this case, place the Hubble Space Telescope in the back, in the trunk, so that we could go outside and get some work done. And that was my job. So myself, along with the 3 other spacewalkers, Mike Good, John Grunsfeld, and Mike Massimino, we had 5 spacewalks that we had to perform over a 5-day period of time. So we did back-to-back spacewalks. I went out on the first day, the 3rd day, and the 5th day, and each time we went outside, we're in the suit for about 7 to 8 hours, and we basically go outside with a bag of water and a diaper and stay outside till we get the work done. Normally for a space shuttle, a space station mission, when we do spacewalks, we have multiple days in between our spacewalks because we need time to recover, we need time to recycle the equipment, but because Hubble's hard to get to, and we only had 1 spacecraft, and this was our last mission, we designed 5 spacewalks that were performed over consecutive days. So after the first day that I went outside with John Grunsfeld, on the 2nd day, John and I were what we called the IV crew members. We were the quarterbacks for the team that went outside on the 2nd day. And then on the 3rd day, when John and I went back outside, those guys that went out the day before, they were inside and they were the quarterbacks for us. So we tag teamed each day and shared those roles and responsibilities and knocked all those spacewalks out in a period of 5 days and got the work done. And fortunately, Hubble's still working. The views from space are amazing in the spacesuits. These are just some shots. That's actually me hanging. You can see my back hanging with one hand on the robotic arm and one hand on the telescope while John's replacing some components. And it's amazing what we can do in space with our fingertips. This is an 800-pound object in space that's bigger than a refrigerator. I'm holding it with the fingertips, and that's it. That's all it takes in space to maneuver, to do anything, to move objects. It's miraculous to know that you've got that power to control things in space because of what zero gravity does for us. And the views we have from the spacesuit looking down on the Earth are amazing. It's not the same view that we see from inside the windows of the shuttle or inside the windows of the space station. We literally, when you're in the spacesuit and you're looking down on Earth and you're just holding on with your fingertips, you really feel sort of connected with space, and you see Earth. And you can see in this image, when we're in what we call low Earth orbit, we don't see the whole Earth like the guys from Apollo did. We just see part of it. But you still get the sense that Earth is a floating blue marble in the middle of black space, and there's nothing else out there. So there's a bit of vulnerability that you feel for yourself and the planet when you're staring down at it, realizing that that's it. That's humans' only home, is that place that we see beneath us as we stare down, just holding on with our fingertips. So it's a spectacular image that you come back with in your mind, and one that we try to convey to people through the pictures that we have and the comments that we make about what it's like to be there. There was a lot of things unique about that mission, but something that was particularly unique about our flight was this was the first time in the history of the human spaceflight program that astronauts had replaced circuit boards in anything in space. So we actually, this is an image of one of the pieces of scientific equipment inside the Hubble telescope, where we removed a cover plate, and these are circuit boards just like in your computer, like the motherboard, and we for the first time ever reached in and pulled those circuit boards out and replaced them with new ones. So that was something that we had to do because there's only so much space inside the shuttle payload bay for us to bring up new equipment. So instead of bringing up a whole new piece of hardware like the size of a refrigerator, the one I was holding in the previous image, we had to actually go in and pull the circuit boards out of this thing. This was being held in by 113 number 4 screws. So anybody who knows how big a number 4 screw is knows that's really small. And one of the challenges for the engineers in development of this mission was, in this case, for example, how do you capture 113 screws in order to get at a circuit board when the last thing you want is like, the picture of the Eagle Nebula with a screw, in the image from the Hubble Space Telescope, So that was a challenge for us. So we worked for 3 years. We designed 100 new tools for this mission in conjunction with the engineers at the Goddard Space Flight Institute Goddard Space Flight Center up in Maryland. And those folks designed us all these new fabulous tools and worked with us hand in hand, alternating back and forth between our time at Goddard and their time at the Neutral Buoyancy Laboratory at Johnson Space Center to make sure the tools and equipment that we had when we got to space were exactly what we needed to make those repairs. We had a little fun in space as well. This looks like an eye infection, but it's actually just me with a ball of water in front of my eyeball. We do some things in space called silly astronaut tricks, and this is one of the things we do is like, let's see what we can have fun with water. What does water do? What kind of fun things can we do? But really the reason we went is because Hubble's so amazing, right? Hubble has told us more about the universe that we live in than any other scientific experiment or equipment that humans have ever made. It's shown us glimpses of deep space that we never knew existed, and to me, these images they're unreal, right? I mean, in a sense, they are unreal because we do some colorization of the energy spectrum that we see, but those structures are actually there in the form of energy, in the form of gases, in the form of atoms, and they make up these things. They make up all the galaxies that are around us, and to me, it's just amazing that these types of things are out in space, these star fields, these galaxies, and most of these images, because of the way Hubble's designed, you could take your thumb in the night sky and cover up the area in space that this represents, which means there's all these stars out there and they're everywhere. So it's hard for me to even talk about it because how do you put words into something that's infinite like this? And Hubble was unique, and I was lucky to be able to be part of that mission, and we were fortunate to have the teams behind us that put all the tools in place, had all the support, the financial support for us, the government, to allow us to fly that mission and hopefully return images and knowledge of space for all of us, for the human race to understand for many years to come. After 13 days in space, we eventually landed at Edwards Air Force Base because the landing site at Kennedy Space Center in Florida was clobbered with weather for 5 days straight. So we actually got some bonus days in space out of the mission because we couldn't come home, and eventually they sent us to Edwards. This was great for us because we got to come home. It was not great for our families because they were all waiting in Florida for us to land. And I'll mention that again with my second landing. But I like to talk about this landing just a little bit because this mission was my first launch, and this mission was also my first landing. So coming home from space is a very unique experience, and I had no idea what it was going to be like when I came home. And I didn't even know until the last second. So there's all strangeness of, coming out of zero gravity and then slowly entering Earth's atmosphere and feeling the load of gravity. And anything you were holding on to while you were re-entering the Earth's atmosphere slowly gets heavier and heavier and heavier to the point that you have to put it down on the floor of the space shuttle because you can't hold it up anymore. Something as small as a phone just becomes so heavy because your muscles and your nerves haven't been firing to tell yourself to hold something up, for a period of 14 days. Imagine a 6-month mission, which is what we do now to the space station. But so coming home, the vehicle stopped. We wait inside the space shuttle because we need to have a crew come and basically help extract us from the vehicle. But what was the most amazing part of the landing was the instant they opened the hatch. So 2 things. I would have hated to be the person on the outside of the hatch when they opened the hatch, because 13 days of astronauts in space is not a smell that you want to encounter, be the first one. But for us as astronauts, when they opened the hatch, what happened was all the desert air rushed into the cabin. And so all of a sudden, I was still sitting in the shuttle, but what I saw with my eyes was the desert. And it was only because I smelled it. I could smell the dirt. I could smell the vegetation. I could smell sort of the mold and the moisture and all that stuff that makes our planet what it is. And it was really overwhelming. I didn't know what to expect. Nobody ever told me about it. But I realized then that the thing about astronauts is, at least for me, is when you're an astronaut on Earth, you want to be in space. That's what we feel like we're here to do. We want to explore space. But when you're an astronaut in space, you want to be on Earth. You look down at the planet and you go, that's home, that's my family, that's where everybody is. And so that landing for me was it was almost as spectacular as the launch and being in space. But, that wasn't quite good enough, so I decided I wanted to go to space again. Because, when you're on Earth, you want to go to space. So I was able to go to space again. I was lucky enough to fly on STS-134, which was the last flight of Space Shuttle Endeavour, which is now the vehicle, of course, of the California Science Center. And our crew of 6 launched in May of 2011. So exactly 2 years and 4 days after my first flight, I launched into space on my most recent flight. Hopefully not my last, but my most recent flight. This was the crew of STS-134. Everybody's a space veteran on this mission. Our commander was Commander Mark Kelly, who is the husband of former Congresswoman Gabrielle Giffords. And we had a lot of challenges leading up to the flight, none that were as tragic for that family as the shooting of Congresswoman Giffords in January, the year we launched into space. So we trained for a year and a half leading up to our mission, and 4 months before we launched into space, Gabby was shot. And at that time, we thought we lost our commander and that the flight was going to basically not fly. And for a short period of time, we had a temporary commander for the flight. But luckily, Gabby's did great in her recovery. She was well enough for Mark to fly into space, and so we flew the mission as planned, as trained, and I think that was ultimately really allowed for us to be successful in space, having that same crew that we had trained with for the last 2.5 years before, or year and a half, 2 years before we went into space. The individual to the left of Mark Kelly is a guy by the name of Mike Fink, and I'll mention him now because up until, I think today, he was the American who had spent the most time in space, 389 days. But right now we've got the twin brother of Mark Kelly, who is Scott Kelly, also an astronaut, who's been in space for 6 months. He's staying for 1 year. So we've got a guy in space for 1 year. He's halfway through his mission, and he just surpassed, or will soon surpass, Mike Fink as the American with the most time in space. So 2 stellar individuals from the flight. Another piece of trivia that I've told Chris Mock about is the guy to the right of Mark Kelly is a guy by the name of Greg Johnson. He was the pilot for our flight. If you remember the last picture I showed you, there was another guy named Greg Johnson. He was the pilot of my other flight, but they're not the same people. So when you see the Trivial Pursuit question that says, who's the only astronaut that flew with Greg Johnson twice and it wasn't the same Greg Johnson, the answer is me, because we had 2 pilots named Greg Johnson. They were different guys. That's the launch, 2011. This time it was the fear of the unknown. Or the fear of the known. I knew exactly what to expect on this launch, and I was still scared to fly into space on the rocket. This one was no alarms, nothing scary, liftoff, 8 minutes later, we're in space, everything's floating, And the destination this time, of course, was the International Space Station. So Space Station is floating 220 miles above the planet. It's about 100 miles lower in altitude than the Hubble Space Telescope. So the view is actually different of Earth. And if you look at this picture, compared to the image I showed you from the Hubble telescope, we actually can see less of Earth here. You can't see as far across the planet. So during the Hubble mission, when we were flying over Texas, I could see my home state of Michigan off in the distance. But on the space station mission, you have to be up around Washington to be able to see up near where Michigan is. So completely different view, completely different perspective of the planet, but also pretty special. I already talked about the launch a little bit, so this was just a great shot that was captured by, I think, an F-15 that was orbiting around the shuttle at the time of launch for surveillance. And when we got to space, here's our crew in space. So this is the point in the program where I ask you can figure out which crew members have been on the beach for the last 4 weeks and which crew members have been in space for 6 months. It should be fairly easy to tell. Maybe the light's it's not as easy in this light, but you should easily be able to tell that the guys in the dark blue suits have tans and everybody else on the left has been in space for too long. So when we got to space, we joined 3 Russian crew members, 2 Americans, Katie Coleman and Ron Guerin, who are across the center, and then to the far left is Italian astronaut Paolo Nespoli, and to the far right is one of our crew members who's Italian astronaut Roberto Vittori. So we had 2 Italians in space with us at the same time during our mission. 3 of the light blue shirt crew members left during the time that we were there, went back home on their Soyuz rocket. We had a lot of work to do when we got to the space station, but we also had some fun. There are musical instruments in space. Greg and I and Katie have all played in a band together, the astronaut band, and so we took a little time to play some music in space. We're a novelty band, so don't get too excited about our skills. We strive for mediocrity. That's kind of our motto. We never quit our day jobs. This is why we flew into space. So what you see in this image is something that has the initials AMS. It's the Alpha Magnetic Spectrometer. That's in the back of Endeavours payload bay. Space Shuttle Endeavour would have never flown into space. That mission, STS-134, would never have been on the books if Congress didn't approve it and if there were not for this experiment. This is a $2 billion science experiment that was under development for 16 years by 16 different nations. And because of that international support and the international governmental agreements that we had, we were able to fly our mission into space to take AMS into space. So that round payload that says AMS was flown into space. We removed it from the Space Shuttle payload bay and actually attached it to the space station structure. So it's permanently there now and will remain there until the space station deorbits. So what does AMS do? So AMS is really designed to complement the work that the Hubble Space Telescope does. The Hubble Space Telescope can see things, right? It can see light energy in space. It can see basically visible spectra and a little bit outside of it. So, well, a lot outside of it, but ultraviolet to infrared. So it's looking at light rays. The Alpha Magnetic Spectrometer is a high energy particle physics experiment that's looking at particles. So cosmic particles that are flying around in space. So it's basically like if you think of an accelerometer, a particle accelerometer on Earth, at the end of every particle accelerometer is a particle detector, and it's trying to look at the particles that are spinning around the accelerometer. The accelerator. Well, AMS is basically a particle detector in space, and it uses the natural space environment to look at those in situ particles that are already going really, really fast. The kind of things that we try to do with accelerators on Earth, those things happen naturally in space. So we put the AMS up there to detect those particles. And so in a sense you could say that AMS and the Hubble Space Telescopes are complements of each other, because Hubble, we learned a few things about space from Hubble. What we learned is there's a lot of space in space. I figured that out on my own. Space is infinite, right? And space is accelerating, like the universe is accelerating. We don't quite know why. So Hubble taught us that, but it also taught us that there's not enough matter in space to hold the universe together. We think it should be expanding at a faster rate. So we think there's 2 things out in space: dark energy and dark matter. So dark matter are the things that are holding the universe together, and dark energy is the force that's causing the universe to expand. So Hubble has taught us that those things exist, and the alpha magnetic spectrometer is really looking to try to find things like, it's looking for antimatter, which they think it's already identified on a number of cases, and it's also trying to figure out what is dark matter, and they're trying to, I can't say whether or not, because I'm just a rock doctor, I'm not a science star doctor. I can't tell you whether or not it's going to work, but they're certainly going to collect data with it until the space station is deorbited and it comes back home. But what I mentioned was, Hubble can see things. So the only thing we really know about the universe is the little sliver of green in this pie chart. That's what Hubble can see in the universe, 4% of the matter, of the makeup of the universe. Everything else we think is attributed to another 24 or 26% or so of dark energy, or dark matter, and then the rest is dark energy. We think it's dark energy. So we don't really know what that is. We don't know what makes up the universe. So Hubble and the AMS are really designed to help us investigate those things. So that's the end of the astrophysics lecture. Thank you. Hopefully there's no astrophysicists here. Anybody? Usually I can get it close enough to the truth that it sounds okay. So we did 4 spacewalks on this mission. I was lucky enough to go out on 3 of them again. For this flight, I was EV1, so I was the lead of the spacewalkers. And so I had a team of 2 other spacewalkers, and in this image, this is me. So that's me hanging out really close to the alpha magnetic spectrometer, which you can see is actually in the image here, placed on the truss of the space station. But you get a feel for how big the space station is. It's the size of a football field in space. It's got about the same square footage as a 5-bedroom home. So it's quite large, and it's very expansive. And so, but that's just the living quarters. So what's out on the other segments that we call the trusses are the solar arrays that provide the electrical power for the space station, and some radiators and some other avionics equipment. So part of our job was to go outside with our spacesuits. We did 4 spacewalks to repair and replace some of the components that are out on the space station. And with the mission, with Endeavour STS-134, we were actually the final assembly mission of the space station. So per the international agreements and the design of the space station, even though it's still growing, the part that was written down in contracts and on paper were completed by our flight. We were the last servicing mission to complete the assembly of the space station. And that was Endeavour that did that work. The view's still spectacular. Endeavour was flawless in space for us. The images that we see of Earth at night are amazing, and I hope and I think most of you have seen some of these pictures of the aurora that we see of Earth while we travel around the planet. We circle the planet every 90 minutes, so we see 16 sunrises and 16 sunsets every day. And we also get a good glimpse of the atmosphere. So this last photo is the only time in the history of the Space Shuttle program that we've actually captured an image of the Space Shuttle docked to the space station. So if you look at the top of this picture, you can see Endeavour. So Endeavour is the only spacecraft that's ever been photographed while docked to the International Space Station. And that was because, as I mentioned before, 3 of the crew members that were in space when we got there, they left in the Soyuz spacecraft. And while they were leaving, as they flew around the space station, they got the camera out and photo documented the partnership between the space shuttle and the space station program, and the Russians as well, because there's Russian vehicles in this image also. And really, without the shuttle, we would have never built the space station, and that's what the shuttle was for, was building this International Space Station that's now continues to orbit our planet, and hopefully will do that till at least 2028. Eventually, we came home, and this little streak you see in the image at the top of this image is actually the plasma contrail of a space shuttle re-entering Earth's atmosphere. And Earth's atmosphere in this picture is that green haze that you see over the top of the planet. So when people talk about the atmosphere and they point up at the sky and they say, look, there's the atmosphere and there's holes in the atmosphere, it's hard to really imagine what does that mean, because we can't see it from here. We see blue sky and we know the atmosphere's there, but you don't really know what that is. But if you look at a picture like this, that haze, it's not pollution, that is our atmosphere. That's the shell that protects our Earth from the vacuum of space. So Earth is actually a spaceship. I mean, the atmosphere is our spaceship that encompasses our planet, that protects us from the vacuum of space. So I like to show this picture so that when people say to you, hey, we got to protect the planet, think about the atmosphere, this is it. This is what they're talking about. That's like an eggshell that's covering us up and keeping us safe. 16 days after our mission, we came back to Earth, landed in Florida. Now remember I mentioned my family last time when we landed in California, which was a bummer because they didn't see us. Well, turns out when you land a space shuttle at night, you also can't see your family members land. So my family, this is about all they saw. They're sitting on the bleachers, and then out of the darkness comes this spacecraft, down the runway, and that was it. So instead of like most day landings where you see this shuttle coming from, miles and miles away from 50,000 feet, all you see is this flash as it goes by the runway. But at least we made it home. We made it home safely. We made it back to Florida where we could greet our family. And this is us standing proud in front of Endeavour on its last flight. And although we look pretty stable in this image, you can see we're actually holding each other up, because when you've been in space, even for 2 weeks, and you try to stand up, you literally feel like you just got off of a merry-go-round. And you feel that way for about 3 days. So it's useful to have another crew member standing next to you while you're trying to steady yourself. So that's really just a summary of my 2 space flights, and I'll briefly mention, hopefully everybody has time to stick around a little bit because we got a few more slides to go here. I want to talk a little bit about what NASA's doing next and sort of where we are now. So we're not flying the space shuttle anymore, right? We know they're all retired. 3 space shuttles remaining are all retired, and we're not taking them to space. It's done its job. Now if we go to space, right now to go to space, we fly with the Russians, launching out of Kazakhstan on this rocket, which is the Russian Soyuz spacecraft. It's very efficient. It takes 3 crew members to space. It's a lot smaller than anything the space shuttle was, but this is the same system that the Russians have been using since they flew Gagarin to space in 1961. So it's tried and true. It's reliable. We use it. We've been flying with the Russians since the year 2000, and we'll continue to do that until the U.S. gets its own capability. And this is the U.S. capability that we're relying on. One of these vehicles on the left is the SpaceX Dragon. SpaceX right now has a contract to supply, does anybody here work at SpaceX? People who know about SpaceX, right? It's right around the corner. And we were lucky enough to visit the floor of the facility yesterday. They're doing some great things there. They have a contract to supply cargo to the space station right now. But they're also working on a crew space vehicle to get us to space. And then the vehicle on the left is the Boeing CST-100. So these 2 spacecraft are being built at the same time, and built in parallel, and we hope that within the next year and a half, we will be launching on these spacecraft, well, maybe 2 years, we'll be launching these to space. We'll still fly with the Russians once a year, but we will use our U.S. vehicles to get us to space and start taking Americans to the spacecraft that we own and operate half of in space. NASA's also working on a spacecraft called the Orion vehicle. This is our heavy lift exploration spacecraft. And in December of last year, we launched the shorter orange one on a test flight 3,600 miles above the planet and brought it back to Earth and landed it in the ocean. And the next launch, which is, I think is EM1, is supposed to launch within 2 years from now, and it will be, I don't actually know where EM1's working or going, because I think we're going around the moon. We're going to do a lap around the moon and come back. So NASA's developing this deep space exploration capability. So commercial crew vehicles to get us to the space station, Orion crew exploration vehicle, this spacecraft on the Space Launch or SLS system to take us back to the moon, asteroids, and hopefully onto Mars. Not necessarily to relive the Martian movie, where'd Cindy go? Yeah, and leave somebody behind, but to take humans to Mars and continue to explore and go further and farther than low Earth orbit and really learn as humans to live off of the planet and continue to explore. So not in my lifetime, well, probably I think in my lifetime, but not in my generation as an astronaut, we will send humans to Mars, and we will see boots on the ground there, and I think we'll see humans back on the moon as well, maybe during my career, that, if I stick around for a little while longer. So For any of the young students in the audience, I'm looking at you too, and you younger guys, Mars is probably going to be in your generation of space exploration. That's what we think. That's what we want at NASA. That's what we're working towards, is to get that capability. Thanks everybody for coming out. Now is a great opportunity for question and answer, so if you have questions, say it loudly so I can hear it, and I'll try to repeat it. And I mean, we learned a lot, so the question was anything to share about Challenger, what we learned from the loss of Challenger. We learned a lot about NASA's management and inability to trap faults and failures that could lead to catastrophic events. Nobody in my era of astronauts was around during Challenger, but unfortunately we repeated those same mistakes with Columbia. And so history seems to repeat itself, and unfortunately it's repeated itself twice with tragic events for us. So we continue to learn and try to trap those things and learn from our own culture and correct those mistakes for the future. That's about the best we can do. How did we find Hubble? The satellite Hubble, how do we find it in space? Well, we always know where it is because we know its orbital trajectory, and we know what we call its state vectors. So we know orbital dynamics helps dictate where it is, when, and as long as and we have ways of tracking it from Earth. So we were able to essentially program in the location of the telescope with the space shuttle computers and help us target specific changes in our altitude and our orbital velocity to catch it and catch up with it. It's the same way we find space station. It's our rendezvous techniques that we've used since early in the Gemini program. Do we have magnets in our boots? No, we don't. On space station, we just float, and same way in space. So when we move around in space, we do everything with our hands, just our fingertips. We don't use our legs at all. In fact, our legs get somewhat, we lose a lot of muscle mass in our legs and even density in our bones because we stopped utilizing them for the periods of time that we're in space. So how many astronauts are in the Corps? Right now we have 45 active astronauts in the Corps, and we take applications every 2 to 5 years. We take new applicants to the program. Generally we get about between 2,000 and 6,000 applications per cycle, and we typically select between 8 and as many as 30 people. We've had some big classes, or 45 in the past. Were we tethered during spacewalks? We're always tethered during spacewalks. We do things a little differently than the Russians do. They tether themselves, but they move their tethers every time they move in space. We have something that's kind of like a fishing reel. It's a retractable metal cable that's either 55 or 85 feet long, and we'll anchor that in one place. And then if we need to go farther away from that, from our anchor point, we bring another one and reconnect that allows us to go out further. But typically, 240 feet is about the farthest we get away from any one point. You don't really need more than that to move around the external area of the space station. If I had the opportunity, would I go to Mars? If it was a two-way trip, yes. Yeah. Would you? No, okay. You might change your mind when you get older. Just okay it with Mom first. All the way in the back, yeah. I would say that every flight we fly has some of those events that occur. So we haven't had any, so the question was, have we had any dangerous events or life-threatening events while we're in space? So personally, I've had a few events that have happened in space that got my attention. All that's been during spacewalks. And then every mission that's in space, even with crew members that live on the space station full-time right now, we are constantly tracking orbital debris, and we on a regular basis have to do what we call debris avoidance maneuvers, where we reboost the altitude of the space station in order to avoid being hit or impacted by those objects in space. So that's a very real risk for us. It's constant. When we service the Hubble Space Telescope, climbing around the telescopes, there's evidence of impacts, of debris impacts that really blanket the telescope. I mean, it's everywhere you put your hands. You see evidence of small little dents and even some holes in the telescope where objects have passed right through it. So that's a real risk for us, and something that's really our greatest risk. The three things that can kill us in space are fire, rapid depressurization, which would be caused by an impact, and toxic atmosphere, which would be caused by ammonia that we use for some of the cooling systems on ISS. And so those are the things we train to respond to and survive, hopefully. Yeah, it's a good question. So the question's related to environmental control within the spacesuit while we're doing a spacewalk. So over a period of 8 hours, we can, depending on the temperature deltas we see, we are faced with humidity sometimes in the suit, or even freezing temperatures. So there's a cooling device on the suit that essentially allows water to flow over the surface of our body through small tubes that are in our spacesuits. So we wear an undergarment to that spacesuit, which is basically one single water line, covers our whole body, and then we have essentially what's like a sublimator or radiator that flows water over a ceramic membrane that sublimates some of that water out into space, so it essentially evaporates into space. And that forms as an ice pack on that surface, and that's our cooling feature. And that we allow to chill the water, and so that water we can circulate over our body. If we get too cold, we bypass that cooling system and allow the heat to build up in the suit. So we're in charge of our own temperature control, and we have to actively chase that, whether we're in the sun or the shade, or if you have a lot of activity or a little of activity, you have to control what your temperature is by turning the dial in the suit. Condensation, so we dry the air out. We have air conditioner in there and basically something that removes the humidity from the air, and that's critical for us to keep that operating all the time, or else you will build up condensation. To re-enter the Earth's atmosphere, the feeling is on the space shuttle is a lot like being in an airplane. It's pretty docile. It's not violent at all. You're sitting in an upright position like we are now, because the shuttle, essentially it's a rocket when it takes off, it's a satellite when it orbits, and it's a glider when it lands. It doesn't have any engines, but so it's a heavy glider with short wings, but it is a glider when it lands. And so you ride in it just like you would an airplane. What I did mention was anything you're holding becomes very heavy. So I was holding objects, a camera that I was using on re-entry, and it became so heavy that I had to lay it on the ground because I could no longer hold it up. Whereas if I was standing here right now, I could hold a camera all day long. You can't do that when you re-enter from zero gravity. Your body's just not used to, your muscles, your nervous system hasn't told your muscles to do what they need to do to hold things up anymore. Oh, do you believe in the existence of God? Yes. The comment was, am I a geologist or a mechanic or an astronaut? I'm a little of both, a little of everything. Certainly my mechanical skills have really helped me as an astronaut, but having the science background really made me eligible for the program. And I do some work within NASA related to geology and geophysics and human spaceflight. But as an astronaut, you really become an operator of a spacecraft. So the skills that everybody has coming in to the program really contributes to their different roles within our office. But for me, being a mechanic was very beneficial and continues to be beneficial for me with the work that I do. Yeah, so what kind of diaper do we wear? We really do use off-the-shelf diapers, and they're like Depends, and try wearing one laying on your back sometime in a chair and using it. That's a mental challenge, because they don't seal as good when you're laying on your back in a chair. Yeah. Do we do resistive exercise training? Yeah, we absolutely do. In fact, astronauts that live on the space station for 6 months are required to exercise for 3 hours every day for 6 months, or in the case of Scott Kelly, the one-year mission, he exercises 3 hours a day every day for a year. And it's we have a treadmill, we have a bicycle, stationary bicycle, and we have a resistive exercise device that's like a Bowflex or a Soloflex, where you're basically operating against an elastic system, forces in both directions when you move those objects. Yeah, why the alarms on STS-125? The first one was a sensor in the fuel tank, I think, for the amount of fuel that was in the tank. The second one was a flight control channel sensor for the solid rocket boosters. I didn't pay much attention because I was downstairs screaming. I didn't really know what was going on. What was wrong with Hubble, and how did we fix it? So there was a lot of things wrong with Hubble, and basically it had been in space so long. The primary reason we went to Hubble was to replace the batteries, because just like your cell phone, after a while, you got to keep plugging your cell phone in like longer and longer during the day because the batteries wear out. And the Hubble telescope has solar arrays that collect energy for the batteries, but eventually they lose their efficiency, and it was getting to the point where the batteries could no longer sustain the amount of energy that they needed to store to feed the avionics and the scientific equipment on the telescope to allow it to keep operating. So we took a lot of hardware and replaced all the batteries and everything else we could while we were there. Did I have to learn Russian at any point? I have been studying Russian for off and on for 15 years. So yes, I have. They've tried to force me to learn Russian, and I'm pretty mediocre at it right now. So don't ask me anything in Russian, please. For Columbia, yeah, so every space shuttle that ever launched into space has what we called transoceanic. Yeah, the question is, is there contingency scenarios for a launch that allow us to land the space shuttle immediately after launch? And we have a couple of those planned scenarios. If something goes wrong, we can return to Earth either after going around the planet once, or going across the Atlantic Ocean and landing, or actually flying backwards and landing at the Kennedy Space Center. The problem that we had with Columbia was we didn't know there was a problem until, well, we really didn't know until we burned the wing off on reentry. They just didn't know. Had they known that, I'm not even sure it would have survived a reentry, a recovery the way it was. Hard to say. Yeah, it probably would not have survived an abort launch the way it was. So 2 more questions, I think, in the back, man. As a geologist, do I see any future in moon mining? Absolutely. I see a future in mining, all planetary bodies or anywhere else in the solar system. I think that there's a great resource there. The challenge, obviously, is the cost and the logistics and infrastructure, but once we have the ability to have a consistent and regular presence in space and the ability to go farther than low Earth orbit, I think eventually you'll see commercialization of resources on other planetary bodies. I don't know what they are now or if we can say what they will be, but I have no doubt that as a natural evolution of our space exploration, part of it will be mining resources on other planets. Chris, the trivia. So this is the last comment and question. And Chris asked about the trivia. The last bit of trivia I could share with you is that, and I talked to Ken and some of the others from the California Science Center about this earlier. Space Shuttle Endeavour is over in the California Science Center, and if anybody ever asks you who the last person was to use the toilet on Endeavour, I can tell you who that was. That was me. So when you go to the California Science Center and you see the toilet on display upstairs, I was the last guy in there. Literally. Okay, Cindy, you had one more comment? Yes, Ken, please share the podium with me. I think. Yeah. Thanks, everybody.
It's a great pleasure to know Drew and to see him again. He and the entire crew of STS-134, minus the guy that they left on the space station. That wasn't very nice of you.
Well, actually, we didn't leave anybody. Our whole crew came and went together, all 6 of us.
Oh, okay, yeah. Great, okay. So, but what about the Italian guy?
No, well, there was 2 of them up there. We brought ours home.
It was actually wonderful to meet the crew, to learn of their dedication. One of the things that they don't usually tell you, but this is absolutely true, is the crew takes as much pride in doing the promotional work regarding the program and supporting education. I mean, they're absolutely fantastic at that. If you ever want to jazz a group of kids, you have a guy like Drew Feustel here come in a flight suit and just talk to those guys about what it means to study hard, do the best you can do, don't be scared, you got your buddies to rely on, and go and explore space. And it is an amazing thing to do, and it's a thing that people can comprehend. I think that's the most important about it. Space flight, it's a very difficult thing to do, takes a lot of training, but everybody gets what it is. You get in the rocket, like Drew said, if you're not too smart, you let them push the button, they launch. And you go to the moon, you go to low Earth orbit. Eventually, you go to Mars.
To get an astronaut in space, it takes an army, really. I mean, we are the lucky ones. I guess you could say we are lucky to have the opportunity to fly in space, but it takes thousands of people around the country, really around the world, to put humans in space, and that won't change for a long time in the foreseeable future. But people talk about going to space and think about the resources that we spend going to space, and I'm hopefully preaching to the choir here, but all the dollars we spend going to space don't actually launch into space with us. we spend all that money on Earth and providing jobs and opportunities and experiences. So we're lucky to go in space, but there's an army of people on this Earth that send humans to space, and in this country as well, and in this local community. And we're thankful to everybody for the work and the career. And I've talked to several folks here today that have spent their lives and their careers supporting human spaceflight, and thank you to them and the work that they've done to allow us to continue on this amazing legacy and hopefully do it for the foreseeable future. Space exploration is just like any other industry. You know, we have to build hardware and we have to fly it in space, so it takes technicians, scientists, engineers, educators, teachers. You know, it starts from the beginning, it starts in school. The motivation for the kids, and then all those people to move into the workforce. Community colleges are very supportive of the tech industry, and also in sending people on to universities. So that's a critical component of what we do, and we encourage people to stay in the game and support their local communities, and encourage folks to keep doing this great work.
I'd like to respond to that. It was a great question. This is statistics, correct me if I'm wrong here, but in the latter part of the days of the Shuttle program, my understanding is it took about 300 people, roughly 3 months, about 1 million hours of work to put an orbiter in space with a crew, 7 to 10 people for about a week, couple of weeks. And so that's the level of effort that it takes on the ground support equipment, all the amazingly talented people that are doing all the monitoring on the consoles, making sure the astronauts are safe on space, helping them solve problems as they come up. Those guys are not alone. The crews are always in contact with ground support, initially at the launch site, then at Houston. So it's a huge team. It's a huge effort. And what's cool about it is that, unlike robotic flight, which is fantastic stuff, and we've got JPL right in our backyard, but the human flight program has guys like Dr. Feustel and others that are kind of like the tip of the iceberg. And when humans are on space station or when they're flying, we care. It's not that we don't care about the robots, but you can lose a robot. It's $1 billion investment. It's kind of a bad thing, but you don't want to lose an astronaut. And so I think that's the thing that really is so important about the support that we all try to give to the space program. You get people up there, and it's like your brothers and your sisters and people people from your community who go to school, they study hard, they do well, they get lucky enough to become an astronaut. You put them on a rocket and send them someplace. You want to make sure they're okay. So that's what it's all about for me. There you go.
Thanks everybody for coming out, and enjoy the rest of the day.
Thank you for watching Peninsula Seniors Out and About. I'm Betty Wheaton. See you next time.